How is everyone? Yeah, tired seems to be the thing. Awesome. All right. I drove down a little wildlife refuge this morning. Oh, wow, that's cool. It's very cool. Yeah, I want to start getting out more and seeing things like that. Cool. All right. Well, so PA2, I finished grading and posted grades and comments. Um, so nice work on the second programming assignment. So most people didn't seem to have a lot of issue in the end. Good use of building on top of other classes. And I tried to dig into your code at least to some degree and see how you were doing what you did. So I ran basically the sample main program from the assignment to check the behavior of your code, and then I looked at your source code, um, and by and large, right, it looked pretty clean, pretty much in line with what we were doing in class. Couple of things to keep in mind, right? So if you felt like you had to do a lot of work for some of these things, right? For example, counting the number of times that a word appears in the list, in the text file, right? That's a single line of Java, right? Go to the hash map, put in the word, get out the linked list, call the size method on that linked list. You can also do it by going through the linked list one node at a time, comparing each node to see if it matches the word and so on. But we're trying to avoid reinventing the wheel, right? We're trying to let these classes, which have these capabilities already provided in them, let those do the work for us. So just keep thinking in that mindset. And PA4 especially, and PA5 will be doing a lot of that. And after this course or beyond this course, if you do things like Android development, for example, it's all about finding the classes, learning what the classes can do, and then putting those together. So we'll be encountering that again in the future. Um, Seeing really good commenting on code, so good documentation, good description of functions, methods, things like that. Still got a few people where you didn't put your name on the code, or you had a half sentence synopsis of what the indexer class does and so on. And I graded kind of gently on those things this time, but you definitely want to try to keep really good habits, right? Try to make sure that you have some sort of standard header with your name, the class, the date, etc., etc. And you're building this indexer class. That's your whole deliverable for this project, right? You should describe it in the beginning of the class, right? What is this thing? And the answer to that is more than create an index. What exactly are you doing? What are the parameters? What words are you gathering? What do you consider to be a word? What do you do with special characters? What is this count that you're delivering of how many times something appears, right? Do you start from 0 or 1? Stuff like that, right? All of that can go in your intro. And you can write that, ahead of time or as you're going, and it can help you figure out what it is you're trying to do. If you write it at the end, it may not happen, and it's after you've already figured everything out, you lose the benefit of trying to explain it. Trying to write this information in the beginning of a project is forcing you to explain it to someone, right? Your imaginary audience. And that's a really good way to try to understand what it is that you're about to develop. So those can be good to do sooner rather than later. All right. So questions on PA3. I'm kind of stuck on what our node structure should look like. I started with the same binary tree setup that's on Canvas, but I don't know what I should have for the structure of each node. Sure. So since this is a decision tree, we kind of need the following information in a node. I would say put in some kind of flag to tell you whether this node refers to a question or an answer. Because that's going to make a difference in when we're processing the file. So something that lets you know if it's a question or an answer. Something that stores the text of that question or answer. So is it furry? Can you eat it? Those kinds of questions. Or, a dog, a cat, a rock, a laptop. Those kinds of answers. And these things, might comprise the data. And then you need to know the yes and no children. So probably 4 pieces of information. So, Boolean, question flag. So true equals a question, false equals an answer, for example. String, text, which would be the actual message that corresponds to the question or the answer, and then a node that we call yes, and a node that we call no. So that would be an example of a structure that would work. This question flag, though, could actually be a method. Because you know that in a decision tree, every node has either 2 children if it's a question, or it has no children if it's an answer. So you could actually make a Boolean Q flag.
Hey Nick.
Yeah.
I can't see what you're writing.
Oh man, my camera's blanked out. Oh no, man. Yeah, my camera is frozen. Alright, let me stop my share. That didn't help. Let me kill my cameras. That's better. That's still there. Alright, well I lost my video of myself, but that's okay, we'll go with this. Alright, let's see, so your node needs 4 pieces of data, a flag to tell if it's a question or an answer, probably a string to store the contents of that question or answer, and then a pair of nodes to point to the yes child and the no child. And then I was just starting to say that we could actually code this flag instead of making it a variable. We could make it a method. And how do you know if a node is a question if it has a child? So you could just return you know, yes is not equal to null.
We cannot see what you are saying, writing, and we cannot see it.
How's that? Hey, technology. Okay. So your Q flag could be a method, for example. Check to see if your node is not null, and if it is, then you know that this node is a question. And if you're an answer node, you have no children, so your yes node, for example, would be null, right? And that is object-y in some sense, right? That lets you not have to keep updating this flag and so on. So either way, so I think those four pieces would work. Let's see, I personally haven't started yet, but when the program gets updated with your answer, does it update a text file, or how does that work? All right, so you play the game, you're following a decision tree. So you come down, you come down, you come down, you get to an answer, you ask if that's the correct answer, it's not, right? So you get a new question from the user, you get the correct answer and the incorrect answer. In memory, you update your tree, right? So change this node to be that new question node with the correct answer and the incorrect answer on it. So first you update the tree in memory. So this is like, you know, in 222 when we update binary trees. You gotta keep track of this node, you gotta make some new nodes, patch them together. And then you take this thing and you write this out to your file. And you never do anything with this file except ingest it in the beginning and then dump your tree out to it at the end. So all your fixes are made inside here. And to do this writing, you do a node left-right traversal of your tree. So the text file looks like this. So text file, you have either a Q or an A followed by a colon on one line just by itself, and then you have either the question or the answer. Q or A followed by a colon, question or answer, and so on. So it's 2 lines per question or answer. And so if your tree looked like this, then when you write this out in node left right, first you write the node at the root, and then you recursively write the left subtree, which in this case is just a single answer node, and then you write the right subtree. So you'll write this, is it an animal, cat, laptop, and just put the Q or A on a separate line before each line of text. And you need to do it in exactly this format because that's the format of the test files that I'll use when I run your program. Alright, does that help? Cool. Alright, so let's talk about ingest. I'll most likely be confused in trying to get the format down and how to write the file. So we talked about print writers, I think. Um, Maybe did we talk about print writers last week? Okay, good. Um, no, there's no 20 question limit. That's just a friendly name. But you just keep going until you hit the end of the tree. So to create the file, right? Write an NLR traversal, which basically, you know, looks at your flag. If it says it's a question, print a Q colon. If it says it's not a question, print an A colon. And then print out the data node. So if you used something like this, right, check your flag, print either a Q or A, then print out the text. And then if the yes node is not null, if the yes node is not null, then call NLR on the yes node and call NLR on the right node. So your nodes have these traversal methods in them. So you can say, you know, yes dot node left right, node dot node left right. All right, so reading in from the database file. So this we rushed through on Friday. So let's work through this in more detail. It's a recursive input routine. So let's call this ingest. And I'm going to pass a scanner to my ingest method. Yeah, the real working traversal code is written in the node class. The tree class has a traverse routine that just calls the root node's traverse routine, and that's how most of the tree stuff works. All right, so this is going to return a tree. So ingest reads from a scanner. The whole trick to setting this up is, you know, open your scanner outside of this. Don't try to open it inside the ingest routine. Open the scanner once, like in your main program, and then call ingest and pass it the scanner object. So here's your file. You know, it's got all this stuff in it. So the idea is you open this up first, and there's, you know, we can think of sort of a pointer that tells us where we are in this file in the process of reading it. And every time we call scanner.nextLine, it's going to return, you know, the next line of the file. And there's something in the scanner class that's keeping track of where we are in the file, basically. All right, and this is going to move as we ingest more and more from the file. But we open the file outside, so this starts off at the first line of the file. But our ingest method just starts reading from wherever it happens to be in the file. Okay, that's the part that's a little odd about this. But if you keep that in mind, how do we ingest? So read a line, which will be either a Q colon or an A colon. So we're always going to call ingest when we're pointing to, you know, one of these flags that says either question or answer. Okay, if it's an answer, then we're just going to return a node. Okay, we're going to return a little tree with a single node in it, which is the text of that that answer. So So read the next line. Let's save that in a temporary variable called text. And then we make a new node. Which has that text and has no children. That's what we return. So build yourself a small tree. Right, make a node, set the answer flag to say it's an answer, set the text, make the yes and no children null, return that. All right, if what you read was a question, then we say, you know, text equals next line. And then we make a new tree where the root node, you know, is marked as a question and has that text. The yes child we get by calling ingest. And then the no child we get by calling ingest. And that's what we return. Okay, this is the recursion part. And do this in steps. Don't try to do this in one line because debugging would be really unpleasant. But, you know, read in the next line, save that as a string. We can just call it text. And then call ingest. The tree that it returns, set your yes node equal to that. And then call ingest again, and what that returns, set your no child equal to that, and then return this. That's the only way I know to read in the file. There's probably other ways you can do it, but they're going to get really confusing. But this is basically reversing what we do when we write something in node left-right order. When we write node left-right, if we're at a leaf node, we just write out, you know, the text of that node's data with a flag that says it's an answer. If we're not at a leaf node, right, if we're at some node in the middle of the tree and we're about to write from that point on down using NLR, what do? First we write out a flag saying there's a question, and then we write the text of the question, and then we recursively call NLR on the yes child. Well, that's what we're going to read in here, is that tree that was written in response to doing NLR on the left. And it's going to, you know, pull in some subset of this file, and wherever that stops, that's where the traversal of the right subtree must have begun. So at that point in the file, that's the beginning of an NLR traversal of the right subtree, the no subtree. And so if we call ingest with our file pointer sitting right there, that should pull in the whole tree that was written in response to that NLR on the right subtree. Alright, so that's your pseudocode for ingest. And getting that working is kind of one of the trickier parts of the process. And so this is where I suggest, right, start with just hardwiring a tree yourself so you don't have to worry about the ingest piece. Right, just make yourself a simple 3-node tree to let you develop the code that does the game playing, let you write the NLR traversal, which is pretty straightforward once you've got the tree class and node classes set up, and then you can work on extending the tree if you want. And you can do the ingest pretty much at any point along the way that you feel like changing gears. But right? You could make a constructor for your node that takes a string and a flag telling you whether or not it's a question. So I could make my root look like this. I could make a temporary yes equals new node. Cat, false. So that's going to be my left subtree, which says, you know, it's a cat because it's an animal. And I could make a temporary no node, which could say rock, and that's an answer node. And then to build up my tree, I could just say root dot yes equals my temporary yes. Root no equals my temporary no. And as long as your constructor is setting the children to be null, right? Now I've got, you know, a root of this basic 3-node tree, and I can pass that to my play the game method, or, you know, call the play the game method or whatever. So yeah, it is recursive, but this is really kind of a classic example of something I alluded to last quarter, which is, you know, at some point, it's actually more helpful not to think too deeply about the recursion, just to kind of let it happen. If it makes sense to you, and it may or may not, because I'm kind of giving this to you instead of having you discover it, but if it makes sense to you what you're trying to do, you can just kind of code it and have faith that that's what's going to happen. You know, at this stage of things, it's probably not terribly helpful to really kind of try to mentally unwind what the recursion is doing. It's NLR traversal, right? Writing the file. I'm guessing that recursive aspect is probably more comfortable than the ingest recursion. But yeah, think about it sort of at the level of how is this undoing what happens when we write things in node left right order. Definitely Inception without the sideways buildings. When you put faith in your code, it should work. It'll definitely change to that the more you do this, and that's part of when it gets to be really fun. But yeah, you should definitely have faith in your code. Import Leo, nice. All right, what else should we talk about for PA3? Said the scanner should be a separate class, right? So in your main program, let's see. Do a main question mark. So in your main method, what do we want to do? Decide what database to read. So check, you know, args.length. If you did main string bracket bracket args, check args.length. If args.length is 0, there's no command line argument. Your database is 20q.txt. If args.length is 1, then you can assume that your database is whatever is in args bracket 0. If args.length is 2 or more, that's a usage error. I don't think I tell you that you need to worry about that. And I'm just going to, I would just pick up the first file name. But definitely check the length of the argument array, because if the length is 0, there is no command line argument. Don't try to open args bracket 0. You'll get a null pointer exception. But if there's an argument specified, then args bracket 0 is the database. So decide which database you're going to read, and then ingest whatever that database file. So call your ingest method. That builds a binary tree. And then play the game on that tree. And maybe you could include the update of the tree and the rewriting of the file in that play game method, in which case this is just an infinite loop. Or you can ask at the bottom, do you want to play again, and so on and so forth. So to ingest the database file, let's call that ingest all. Well, we don't have to get too. You could construct your scanner inside main if you want, right? So scanner SC equals new scanner database file. And then down here, you could just say ingest SC. And then you can use this structure that we were using over here. But you know, if you really want to go modular and top down, right, you could just call some ingest all method on that database file, and that ingest all method could try to open the database, you know, create a scanner, and then call the ingest method that does its recursion. But what you don't want to do is, you know, inside here, you don't want to open the scanner. Right, because every time that you call this recursively, that would be, you know, creating a new scanner that would start from the beginning of the file. So you want to open the scanner before you start this recursive method. So that might be what you interpreted as saying it should be a separate class. It's really, it should be done outside of the recursive calls. And then this play the game method looks something like this. So start at root. If you're at the root, print out the question with a question mark at the end. Get an answer. Move your temporary pointer to either temp.yes or temp.no based on what the person's answer was, and go back up here and iterate. Okay, if it's an answer, state the answer to the user. Were you correct? If yes, then you can go back up to the top and play again. If no, get a new question. Correct answer. Make tree. Adjust your decision tree and then write the tree to the database file. And then go back up to the top. So writing back out to the file would happen down here. at the end of playing the game, after you've got the new information to improve the tree and you've updated the tree in memory, right? Then you go ahead and write the tree out. And that's just calling an NLR traversal method on the tree object. Or the node object, depending how you organize it. So it's not so much separate classes that we're thinking of, right? We're really thinking of classes and methods, right? Classes are sort of the collection of code and data that we group together as one logical thing. And we definitely want a class for trees. We want a class for nodes. We have a class for our main program. But that's probably all you need. But within our node class, there's going to be a traversal method, right? Within our main class, there's going to be a main method that gets run when we first start executing our program. There's probably going to be an ingest method somewhere in one of those classes, and so on and so forth. Is there an advantage to doing this outside of main? Well, it's kind of an organizational thing. It depends. So personal preferences, right? I like having clean main programs. I like to look at the main program and see, what we call a system diagram in Engineering 250. Inputs, outputs. What do the inputs mean? What do the outputs mean? Not a whole lot of detail about what happens in the middle, right? What's in that box. So we're going to figure out a database, we're going to open it up, we're going to read it in, we're going to play the game forever. Right? It's more of a 40,000 foot view. I could play the game and I could return a Boolean to say, did you win the game? And if you didn't, then I could go ahead and ask, some questions and get some information from the user and patch that up. And now half my main program is about, this detail that happens at the end of playing the game. And half my program is this stuff that happens once in the beginning and just kind of initializes things. And that's feels kind of unbalanced to me. I sort of like the lines of my code to kind of have the same weight in some sense. Right? If this is something that's going to be done once and just initializes something, and this is something much more significant, right? I don't know. So it's largely personal preference. So if we were to put ingest and file write methods in main, they would need to be static methods, right? So yeah, calling methods in main does get to be trickier. Yeah, so then you would get into statics. That's another reason I don't put methods in main sometimes. But it's also, you got to think about what really makes the most sense. For the ingest method, should that be just a method that I pass a tree to, like I've done it here in pseudocode, or should it be part of the class? Right? If I define a tree class, should I have a method called ingest? In which case, main might look something like this, tree, my decision tree, and then I could say dtree dot ingest file name, right? Because ingest really doesn't feel like it should be part of your main method. It's really something you're going to do with trees, right? And so to me it feels like ingest should be part of the tree class, or maybe the node class, or maybe both. And so if I wanted to do the ingest from the main program, right, I would invoke that code as part of the decision tree object, which is an object of type tree. So yeah, you can avoid statics. And don't be afraid to write this more than once. Right? This is another reason why I suggest, starting off small, put yourself, build yourself a small tree, just, hand wired in code, and start working with that. It's totally reasonable to write your code, several times in the course of developing a project, especially if you've got 2 weeks for it. Start down a path of, building this, and, partway through you say, really, all of this stuff should have gone in this other class, or I should have taken all the stuff out of that class and put it somewhere else, right? And nothing wrong with starting over. I mean, keep your code and make a new, version of it or something, but a lot of times the better way to organize something comes to you by, just picking an organization and working with it, and you get partway through and it's like, oh, I should have sorted my CDs by year instead of, artist or something. And you go back and do it again. And that's part of what you're trying to develop is your own sort of intuition for how to organize larger projects like this. This will kick in a lot in PA4, especially PA5, and classwork beyond Clark. You're gonna be working on large projects with lots of different parts and pieces. You're gonna be working on group projects, with 3 or 4 other people, where each of you is working on different parts of this. The organization is going to be really, really critical, right? Thinking about how do we split this up? What are the logical pieces that go here versus there? So this is all, good practice for that. If you write methods in the main class, yeah, they tend to have to be static. Oh, let me just do this from my... Alright, so here's an example of got your main program, you got a function that you're going to call. Right, and you compile it, you get this error: non-static method myfun cannot be referenced from a static context. Okay? When you get this, right, take a breath and step back and think about what you're doing. Because you can start, adding the keyword static places, but it may be that you're trying to patch up something that shouldn't be there in the first place. Okay? So what's going on here? When I say Java main to execute a program, so this is all under the guise of statics. When I say something like Java main, what the JVM does is it looks for something with a signature. Right, it looks for a method named main, lowercase, that will accept an array of strings. And it has to be a static method because the JVM is going to execute this by saying the name of the class, main, which I specified on the command line when I said Java main, name of the class, dot, name of the method it's going to run, which is always main. Right? So that's got to be a static. If I didn't make main a static, the JVM would have to do something like this. Main m equals new main, and then m dot main, and pass an array of strings. Right? So we don't want to do that. So it just calls it as a static. But what that means is that, this is being executed without being called from an instance of main. Right? There is no m object of type main that was constructed. Right? This is called statically as a class method. And so if I call myfun, well, when you call myfun, when you call the area method in a rectangle, right? Why does that work? Why can we get a hold of the length and the height of the rectangle? Because we're saying, rectangle R, and then we're saying R dot area. And inside that area method, we're inside this object R, right? This thing that has a height and a length, right? Well, there is no object of type M in this case that we're sitting inside of. We're just running this as a static method. So if we try to call a function, right, a method that for example, that used this flag, the meaning of that flag doesn't make sense, right? If we had an object of type M, then that object would have a flag value, but we don't have an object of type M because we're running this statically. And so in the same sense, we don't have a method myFun that we can access, right? If we constructed an object of type M, we could say object.myFun, but to just say myFun when we run statically, there's no object there. So the compiler will complain and say, this method is not static, but we're calling it from a static method. So we can fix that by doing this. But then if we tried to do something like this, right, so if our flag is true, we're going to return 0, otherwise we'll return 2 times x, right? Same problem. We've got this variable flag which is not statically declared. We can't access that from main because main is a static. So there's no value for this thing. If we want this thing to have a value as part of the class itself, we could say static Boolean flag. But if you start down this path, what you end up doing is just throwing the keyword static in front of every variable and every method, and no clear idea why you're doing that, and that's almost never the right thing to do. Right? So it's not like statics are evil, but they can be confusing. And following the guidance from the compiler saying, this is a non-static flag and we can't access it, so I'll make it static, right? Probably isn't going to get you. It might get you something that compiles, but it may not work the way you think when you actually run it. So that was a long answer that didn't really answer the question, but hopefully that helps. Cool. All right. Other questions on PA2 or anything else? That's pretty much always going to be your best bet. Get your hands dirty. Really, for me, like if you're trying to paint and you're staring at an empty canvas, right? Or you're trying to write an essay and you're staring at a blank piece of paper, right? So people can get brain locked staring at, an empty editor window. Where do I begin? Begin with something, right? And again, starting with a hand-built 3-node tree, well, to make that work, you got to implement the tree class, you got to implement the node class, and grab the sample tree code from Canvas, from the shared code area, and put that in and start working with it. It's a binary search tree, but get that working. Get familiar with the idea of calling something from the tree versus the node, and then modify the structure a little, the way that we talked about in the very beginning. When my camera was invisible, to describe, a flag for the type of node, the text, a yes and a no child. Put those together and then start building from there. And yeah, it will click. It will click multiple times as you do this. But yeah, definitely start with something and build from that. That's going to be more successful than trying to sort of figure the whole thing out before you begin writing. And compile and test as you're writing. Right? Get one piece coded up, compile it, test it. Right? Get the next piece figured out, code it up, compile it, test it. So that by the time you get to your first version of the final program, it's almost going to be perfect, right? Because you've tested everything up to that point and got it all working. All right, so we are out of time for now. So I want to start talking about class extensions tomorrow. And this is going to take us into our next topic, which is going to be working with GUIs. And I also want to talk about how to get Eclipse installed and running. So I'll start with a native VirtualBox setup, and we'll go through from beginning to end, getting Java and Eclipse and Window Builder set up. And that'll be what we're using for PAs 4 and 5. All right, cool. Have a good afternoon. I will see you tomorrow.